In our previous videos, we talked about the energy and the wavelength and the frequency of a wave and how, as those electrons move around within the atom, the amount of energy can vary depending on what atom you are referring to. So now what we're going to do is we're going to talk about how the electrons are organized in an atom. And when we talk about how they're organized, the word that we're going to use, we're going to talk about the electron configuration of an atom. And again, all that means is how are the electrons organized in an atom. So when you talk about, for example, a carbon atom, we know that we've learned already that carbon is number 6 on the periodic table, and therefore it has 6 protons and 6 electrons. And again, we're going to focus on how those electrons are organized within the atom. Okay? Then there's two different types of what we call electron configuration. There's one called the ground state and one called the excited state. Okay, most of the time when you find an atom, all of the electrons are in their lowest possible energy level. That's what we refer to when we say the ground state. Okay, when electrons start to move around in an atom though, and they move to different energy levels, then that is what we call an excited state electron configuration. For now, all of the electron configurations we're going to do are going to be ground state electron configurations, which means every electron is going to be in its lowest energy level possible. Now, the first thing that we need to do to understand this is to talk about how the electrons are organized. Is we're going to take a periodic table and we're going to put a 1, 2, 3, 4, 5, 6, 7. So on the periodic table that you have or should have, you can go ahead and do that. Okay? And then another thing you can do is we're going to take, first of all, we're going to take helium that's over here and we're going to move it and we're going to put helium right here just for what we're doing. So helium is no longer here for electron configurations. Okay, and then this whole section here, including helium, is what we're going to call the S block. So those first two columns are called the S block. This middle section here, we're going to use the letter D. Over here on the right-hand side, this blue line here doesn't need to be here. It's that whole section here, and same thing here. This red line here doesn't need to be there. Okay, that is the P block, and then we also have the F block, okay? And what these letters represent, the S, the P, the D, and the F, what they represent is they represent subshells. So within each atom, there are what we call shells or energy levels, okay? These numbers over here represent the shell, the 1, the 2, the 3. That represents what shell is that electron found in. Okay, and then within each shell, there are what we call subshells. So shell is the big thing, and then we have subshells, which are within that shell, you have some subshells. Okay, and that's what the S, P, D, and F stand for. Okay, and so what we do is we simply find the element on the periodic table, and then we rewrite what shell those electrons are in and what subshell those electrons are in, and then that's it. That's all really what we have to do. And once you get this, hopefully this is going to be pretty straightforward. So let's start with the element with the fewest electrons, which is hydrogen. Okay, hydrogen only has 1 electron. Okay, and so we look at where hydrogen is on the periodic table. It's right here, and therefore its electron is in the first shell, and it's an S subshell. So therefore, for hydrogen, we write 1s, and then up in the corner here, you put a 1 to represent that is the actual electron. That's the E minus there. So that means that hydrogen has, again, 1 electron in the 1s subshell. So it's in the first shell in the S subshell. And the way that you say that, if somebody says, what's the electron configuration of hydrogen? You would say hydrogen's electron configuration is 1s1. Not 1s to the first power, just 1s1. Okay? The second element is helium. Now, helium, like I said, remember, we moved it. It's right here. We're still in the first shell. Remember, you don't switch shells until you go down to here. And then from the second shell to the third shell until you go down to here. So this whole thing, for example, right here, all the way across, all of that is part of the second shell. Okay, but helium is still in the first shell. So notice, like with hydrogen, we're still in the 1s subshell. But notice that the electron configuration of helium is not 1s1, it's 1s2. Now, why is that? Well, because helium has 2 electrons. Hydrogen here, number 1, only has 1 electron. Helium has 2 electrons because it's number 2 on the periodic table. So the electron configuration of helium is just 1s2. And that's all you have to say. Hydrogen's 1s1, helium would be 1s, and then again, that 2 up in the corner represents how many electrons it has all total. Okay, for lithium. Okay, lithium is number 3 on the periodic table, so it has 3 electrons all total. Now, before we continue here, remember, well, yeah, lithium is in the second shell. You're right, lithium is right here, and it has electrons in that second shell. Okay, but what that also means is that lithium also has electrons. It has 3 electrons all total. And you can't put electrons into the second shell until the first shell is full. And you can't put electrons into the third shell until the second shell is full. That's what this principle right here is, called the Aufbau principle. Don't need to remember that. But you have to fill the lower energy shells or the lower energy levels before you fill the higher ones. Okay, so with lithium, yes, lithium has 3 electrons. But those first 2 electrons aren't in the second shell. You always start in the first shell. So you completely fill up the first shell, then you go to the second shell. Once the second shell is full, now you go to the third shell, and once that one's full, you go to the fourth shell, etc. So notice that lithium is written as 1s2. So basically, we're now to helium. Once you've filled up that first shell to helium, now you go to the second shell. So now we're at the second shell, 2, and we're still in the S subshell, and lithium only has 1 in there. Okay, so 1s2, 2s1 is how you would write lithium. And notice that lithium all total, again, has 3 electrons. If you add up these numbers in the corners, the 2 and the 1, that equals the number of electrons it has. Okay, so beryllium. I didn't do this one for you. Beryllium's right next to lithium. Okay, so let's think about this. If lithium is 1s2, 2s1, and beryllium has 1 more electron, but it's also in that S subshell, then instead of 1s2, 2s1, beryllium would be 1s2, 2s2. Okay, and that is the correct electron configuration of beryllium. Okay, now let's keep going. Let's go to boron. Now boron is over here now. Notice that boron is in a p subshell. Now, how many electrons does boron have in that p subshell? Just the 1. Okay, so we got to be real careful here. So boron is going to start similar to beryllium. 1s2, 2s2 takes us to beryllium. And again, now we're going to go into that p subshell. So 1s2, 2s2 gets us to here, to beryllium, but now we have to jump into that p subshell. And again, we're still in the second shell, but now we're in a p subshell. So now we're going to say 2p, and notice it's just 2p, and beryllium or boron just has that 1 electron in that 2p subshell. Okay? And again, the way we would say that, 1s2, 2s2, 2p1. Okay, what about carbon? Carbon is right next to boron. So boron was 1s2, 2s2, 2p1. So therefore carbon would be 1s2, 2s2, 2p2. Okay, because carbon, again, right next to boron here, now has 2 electrons in that p subshell. And then what comes next? Nitrogen. So if carbon's 1s2, 2s2, 2p2, nitrogen would be 1s2, 2s2, 2p3. And then oxygen would be 2p4. Fluorine would be 2p5, obviously with that 1s2, 2s2 at the beginning. And then neon, the very last one in that second p subshell, therefore would be 1s2, 2s2, 2p6. Okay? Now now that second shell is full, now we can jump down to the third shell. And hopefully you're starting to notice here, gosh, Mr. Johnson, it's kind of like you're doing the same thing every time to start. Yeah, you are. Okay, magnesium that's right next to sodium is 1s2, 2s2, 2p6, 3s2. Okay, sodium's 3s1. It's right here. Here's sodium. And so magnesium is right there next to it. And it's going to be 3s2. Okay, and then we can keep going. Now after magnesium, where do we go? We jump over to the next side. So phosphorus, let's see if we can do these together. 1s2, 2s2, 2p6, 3s2. And again, really what I'm doing here, guys, is I'm just following the periodic table. Down here, I wanted to kind of show it to you first. But notice it goes 1s. This 1s actually goes here. 1s, and then 2s, and then 2p, and then 3s. You're literally following the periodic table. So phosphorus is right in here. It's in the 3p subshell. So 3s2, 3p3. And again, how many electrons does phosphorus have all total? 15. Add up these numbers in the corner. 2 plus 2 plus 6 plus 2 plus 3 equals 15. Okay? And then our last one here in these examples is calcium. Calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, and that does equal 20 all total, and calcium is, again, adding up those numbers in the corner, is going to add up to the 20 electrons. Okay, so as you're practicing this, just know that, again, follow the periodic table. Find the element on the periodic table. Oh, I have to do chlorine? Okay, chlorine's right here. Always start right here and just follow the pattern. And the more you do it, the easier and easier this is going to get, okay? So we're going to go ahead and stop right there for now. So we're going to stop right here. We're not going past that point. So any homework problems that you have are going to be from hydrogen to calcium and nothing beyond that for now.